We are here with Travis Oliphant, creator of NumPy and one of the founding contributors to SciPy, longtime member of the Python community, and now a documentary star. You're in a documentary, Travis. How cool is that?
Wow.
Wild. Yeah, actually, they did a great job. It's impressive what a good media creator can produce.
Yeah, it's really cool. The Python documentary coming out soon. The trailer is out there if you're listening to this and you can't find the entire thing will be out soon. But I just think it's a strange world we live in where like a bunch of nerds who write programming languages are the subjects of documentary, and there's no scandal. There's not like murder or anything interesting. It's just like,
There are some interesting things. There's some interesting things you can talk about. We didn't get into some of that.
Yeah, there's some drama and stuff.
There's
like
drama.
What kind of interesting stuff has happened?
Well, there's people have different ideas about how community should be run and about how projects should be governed, and there's different kind of scandals. We had the Dongle gate at one PyCon that probably didn't make the documentary because nobody wants to talk about it anymore. We had, which is totally fine.
Yeah.
We had the introductions of so it's just some really, it's people, right? And there's some awesome people, but then people end up rubbing each other the wrong way a little bit.
Yeah.
And then how do you deal with that?
Well, like iron sharpening iron, that's how it works, and it hurts to do that work, but it betters both sides, hopefully for the best.
Hopefully, and there's definitely ways to do it.
There was the Python 2, Python 3 transition. I'm trying to think of the dramas. I don't know what Dongle.
Oh, that was a big, Well, that was just a PyCon. Let's call it codes of conduct.
Yeah, okay. I can guess
how do you handle? You can guess what it is. Codes of conduct and how to appropriately have public events with lots of different diverse people coming, and how to then just managing that and managing expectations and helping people feel comfortable and not making it a safe space for lots of people. Mm-hmm. Then as you're making it a safe space for lots of people, making sure everybody who is also still welcome, because there's definitely people that end up not coming. There's the whole people being some of the original contributors. We get a little older, and then maybe we're not as we don't choose our words well enough, and ultimately get maybe even from offending somebody to inadvertently to kind of the style of engagement being unacceptable anymore. Mm-hmm. And so there's definitely some of that's going on I would put that under that's been managed pretty well, but there's definitely, I talked to a lot of people, and there's some people who are feeling less welcome in the community than they used to. And that's something that maybe is okay, or maybe it's like, well, there's room for other communities. There's places to have, I call Python an ecosystem at this point.
Yeah, I was
because
gonna say,
it's not
like
just
so
one
big
community. It's so big.
A community even?
No, it can't be a single community. And actually, that's one of the things for the major leadership of the Python, the Python Software Foundation or the ecosystem facilitators understand. I think that's one of the primary things I could articulate this under, is just as you get so big that you're actually encompassing many nation states effectively, how do you be the UN as opposed to an organization that's running one country, county, city? Like the skills and what you have to do is different. And how do you do that without effectively making it feel like you're a bully or a totalitarian for one group for other groups? Because that's what ends up happening, is some people feel unwelcome, not because they're intending to, but just because, well, we're limited. Every human is limited, and if you have an organization, it still has to be ribbed. People have to do work. They have to do stuff. And if the stuff they do just isn't feel inclusive enough for other people, then those people start to feel annoyed. So what are the patterns? And Python is definitely big enough for that. And you'll see issues on this over and over again, whether it be the documentary didn't cover this group enough. I'm sure we'll get that. Sure. I'm sure it's true. The documentary, I'm just like excited to see anything talked about that emphasize a couple of great points about Python, that it's been such a great group of people who have tried to bring their best foot forward and try to do what's best for each other. And check ego at the door, not perfectly, of course, because none of us can, but try to be inclusive, try to bring other people in, try to manage the growth and different mindsets that are there. I understood very, very well the difference between let's call it the developer mindset, the person who's using Python to build a website and then from there a system prompt or a script and operating system or build a event programming system, versus somebody who's using this to run a scientific experiment or to do math or to run physics systems, and now evolving into data science and AI. Like the kinds of problems they have and the needs they have are different than somebody building a website or a database or a Raspberry Pi, right? Or a web app. All great, all wonderful. There's not there's no judgment about which is more important. It's just simply different. And then as they come together, how do you have a language support all of these use cases? Great question, right? I think it's challenging, but the community is awesome. I think one thing that comes out in the documentary is very true, is people come for the language and stay for the community. And that has to do with kind of, the original group, Guido, his original personality and approach he took to engaging with people, and the group of people that came around him in the early days, and then how that spawned multiple subgroups. Even from the very early days, they had these SIGs, special interest groups they created, just to allow other communities to form instead of just all one mailing list. In other places, hey, you could talk about that problem over here and not be, and everybody didn't have to chime in on that problem if they weren't interested. And so people have these special interest groups. And that special interest group is the matrix SIG, actually, that ended up giving rise to numeric and then NumPy and then the SciPy ecosystem came out of that special interest group. And then you had other special interest groups that gave rise to Django and Fast API. And then there's packaging that's its own story that we can go on about because there's still challenges there. But so I think that's one of the key things to understand. But each of those interest groups was infused with at least a general sense of, hey, here's how you treat people. Here's how let's avoid kind of even though, we want to make sure excellence is achieved and people do really good work and not just lowest common denominator code gets in, it's still, how do you make it welcoming? How do you make it so there's new people, they don't feel scared away because they're not capable enough or the people who they feel they're not capable enough. How do you make it so that they feel welcome, but then also you respect the quality of the code and that people are attentive to that? Sometimes in some areas I shouldn't be contributing code, right? The code I write should be tossed out. Yeah. But I appreciate being listened to. At least if somebody tells me, this is why, that's always better than just being ignored. So I think some of those elements of the Python community have been helpful. Not perfect, each of these communities. In the Jupyter community, the notebooks, the data frame community, pandas emerged from the kind of the SciPy ecosystem. SciPy was an ecosystem that gave rise to data science, AI, scientific computing, and each of those kind of have developed their own stories. Jupyter, one of the things we did early was, not early, 10 years in 2012, we created a nonprofit called NumFocus. So I was heavily involved in creating that nonprofit NumFocus. And the purpose was because I wrote NumPy and it had no home except in a company. And I didn't want, and the community didn't want, a single company to own the domain and own the IP of NumPy. It needed to be a community-driven thing. So where's that going to live? But I can go back in the history before we get ahead of ourselves if you want. So, love to kind of can talk about the different things that you think are interesting.
For sure. Adam, where would you like this to go?
I don't want to dwell on the Dongle, but I do recall that stuff. I think I think every community's got a version of that. I think, what I'm going to say to you is don't apologize because it's going to happen. Not that we should allow it to happen, but, we've all got growth. And growth matures with scars from previous battle wounds, whatever it might be. And I think it's all about trajectory, which is probably why Python succeeded so well, not just because it's a great language, but because, like you said, you came for the language, but you stay for the community. You have to have a way to bounce back from things like that and handle things well. And I think we've known Brett Cannon for years. We've never met Guido, unfortunately. Guido, come on the pod, man.
Come on, man.
Yeah, I know he's doing less of that. I actually asked him specifically. He's like,
Brett's asked him for us. It's a long-standing thing. We have drama around here,
Well, Guido's a great guy, but he definitely has a lot of people asking.
Oh, for sure. Yeah, for sure. So,
I appreciate him.
NumPy, take us back to the language for you. Like, what were you doing before that? What brought you to Python? Why'd you like it? Why'd you pick it for NumPy, etc.?
Yeah, great question. So I am a scientist. I was a electrical engineering student who went to the Mayo Clinic to study medicine because I wanted to help diagnose cancer and diabetes, and instead of make bombs. Right? I loved applied math. I loved electromagnetism, and I loved signal processing. And then I had this opportunity to go to the Mayo Clinic to study. And initially, when I was a master's student, I was measuring wind speed. I was measuring backscatter radiation from the planet in satellites. It's called satellite scatterometry. And then from the information from that signal from the satellite, you could infer wind speed. You could also infer other things like vegetation coverage, ice coverage. In the lab I was in, we were doing that kind of Earth observation at the time. I was using, I was on a VAX VMS actually back in the day.
Okay.
We were using, I was programming C, Fortran, MATLAB, and then some Perl. So I just started to pull out Perl, and my experience with Perl in the back 94, 96, I would write it and like, okay, this is pretty cool. I can do the scripting, I can write some code. But then I'd come back 3 months later, a year later, and I had no idea what I'd written. It was like it was write once, read never, right? And very interesting. Like ideas were there, and it was cool, but that was my experience. And so as a domain expert who was using coding, I couldn't use it because I couldn't understand what I'd written past. So fast forward to 97, I'm at the Mayo Clinic doing work on magnetic resonance elastography, trying to measure. I'd take a big MRI image and look at the phase of that image to infer motion. And from that motion, you could see a kind of a propagating wave inside of tissue. You could then try to figure out the elasticity, like how stiff it is, and make a picture of elasticity. So that was the problem I was solving, and I needed to find derivatives and compute them on essentially 4 or 5 dimensional data sets, so big data sets. And MATLAB I was using MATLAB a bit, but I ran out of space and I didn't have enough, I couldn't change the precision well enough, so I was looking around for other ways to do this. Now I could just write C code, but man, when I write C, I'm spending a lot of time on pointer arithmetic and figuring out where memory references are, and I want to be thinking about my problem, which is here's my volume of data, and I want to do derivative calculation. So if I have to write that, if every line is like 10 lines of C, I lose track in my mind of what I'm doing very quickly. So that's what a high-level language did, is give me a chance to be in my domain writing some scripting or high-level conversations, but I needed to be fast, I needed to be efficient. So I was looking around for ways to do that in 1996, 97, and I came across Python. Python was pretty new. It had been around for just a little bit, and it had an array library called numeric that I learned later had been written by Jim Huguenin out of this matrix sig, which was formed in 94, right? And the language itself was written in 91, but I came to it about 97, right? And it was still early, still nascent, kind of this thing on the net that a few people were doing, and it wasn't being broadcast or promoted by anybody but the people who found it, and then started to share their experiences. So I found, oh, this language actually feels familiar. It's like high level enough that I don't have to, the syntax doesn't get in my way. I'm not worried about chasing pointers, just a straightforward language that also can be extended. So if I had C code that did something fast, it wasn't like, good luck, run that in a different process. It was, that's fine. You can actually load that in a shared library into the language, and you could extend it. And numeric had already done that to make an array object. So if numeric hadn't existed, I would not have used it. I would have been using something else, very likely. So Jim Huguenin and the matrix sig, Conrad Hinson, Paul Dubois, they were hugely influential in making that happen. And they don't get mentioned a lot anymore but they were the OGs of array computing in Python. And I'm leaving off names. David Asher. I mean, you look at there's a NumPy book. What I did early by about 98 is I made a chapter in the first numeric documentation that particularly covered how the C API worked. How if you're a C developer, how do you use numeric and make an extension using that? So that's what I became really kind of known for, and what my super skill was blending Python and low-level languages and releasing libraries that could do that. That's essentially what I learned to do as a grad student at the Mayo Clinic. So fairly straightforward, very specific. I had the opposite experience from Perl, because I started in 97, I wrote some scripts to do some things. Fast forward a year in 98, I come back to the language, that script, say, I did that script to load those data and do this math. And I understand what I did. Like I can still read this. This still makes sense to me. And so then I was kind of hooked. I went, oh, this can work then. And so 98 was the start of my journey, and then 98, 99, SciPy really was really created in 99. You can see on the mailing list, the early mailing list there, posts from me, like probably every 2 months. I'm like, here's a new module, here's a new library, try this out. And just, posting a tarball. That's how we did it in those days. Here's the mailing list, post a tarball on a web, and you could go to my website. My website was really dumb, just had a bunch of links, hyperlinks, not pretty at all. and you could download it, and they'd download it, and you'd unpack it, and then I would get patches. I get patch files. People started to send me patch files. And I went, oh, this is cool. Someone from anywhere in the world is sending me code, and yeah, that's better. Yeah, that's cool. Like, and then I decided to adapt it or not adapt it. So I did that for about 7 different modules between 98 and 99. And then a few other people started the same thing. One of the guys actually helped me. He saw what I was doing because the modules I was writing, it's things like ordered differential equation solving, integration, optimization. It's things I needed for my research. So I'm like, oh, where's the library for that? Okay, well, here's some Fortran code that does it. Then I just write the connector to Python to make that work, and then push that together in an extension module, release it, and then tell people how to install it. But to install it, you had to literally compile it yourself on your code. Right, so that's what I did, and then around me, people started to show up. Right, it's sort of this people in the community started to show up. One person showed up and said, "Oh, let me build a binary for Windows installers," and they did. They wrote a binary installer for the predecessor to SciPy called Multipack, and then somebody could just go to the website and click and an exe they could install in their Windows box, and they could start using it. Right, and that was huge. So all of a sudden, usage went up about 100-fold. Right.
I bet.
And that's actually why a guy like me ended up starting a company like Anaconda, right? Which is all about getting the tools in the hands of people easier, right? Because of that experience of like, oh yeah, that was a big deal. Helping people actually get this stuff installed and used easily is a big deal.
Yeah.
So anyway, that's how I got started. It was that awareness of, oh, this works. And then the enjoyment of engaging with community-driven development. Of people, I share it, people come, they add things to it, and you have this community on the mailing list. And I finally, I think, went to a Python conference, probably, I think it was 2000 before I went to my first Python conference. I don't really remember, but then you go to a conference, and then we started our own SciPy conferences in 2001. So I'd gone to a Python conference before, then we started our own SciPy conference in 2001. And man, that just hooked me, right? You go and you have these engagements with people, and it's like, yeah, these are my people. This is my crowd. And I had done a lot of scientific conferences. I'd gone to published papers and gone to MRI, ultrasound conferences, and I liked them. They were also very interesting, but a lot of those conferences, it ends up with people competing for grants and for notoriety. And so there's not as much collaboration that goes on in those conferences. A little bit does, but a lot of times it's, you give your presentation to an audience of people staring at you and not listening, and then you get some questions, but people would come up and they'd answer. The question would be something like, this is interesting, but have you seen my work? Why didn't you incorporate my work? And it's like, well, okay, that's, I didn't mean to offend you, but I'm just, right. So there's a lot of that going on. And the Python conferences, I found a lot more collaboration. How do we build it? And part of it's because it's a practical problem, solving a problem for people, and they're using it, they're scratching their itch, they're solving problems they have. And it just created a space for that to happen. And it was beautiful. So the SciPy community inherited a lot from the Python community, but kind of organized its own story. So SciPy came around in 2001 when Eric Jones and P.R. Peterson, and Eric Jones and that's a separate story, but Eric Jones and P.R. Peterson have been also writing some modules, and they said, hey, why don't we blend these together and make a single thing called SciPy that you could download. And SciPy was really a distribution of a bunch of these modules in one place, masquerading as a library. And we spent a lot of work kind of making the library work with different modules and different, there's optimization, there was integration, there was special functions, there was a lot of things so that somebody could use Python instead of IDL or MATLAB or some other scientific computing tool. And initially, we were trying to get like plotting in there and a user interface in there, machine learning in there, statistics is in there. But eventually what happened in the SciPy conferences is people started to go, okay, this is cool, we really love this, but man, this is a big area, this is a big ecosystem. And having all these ecosystems trying to be managed from a single governing spot is going to be hard. Just bandwidth constrained. How are you going to decide what goes in and what stays out? And so there was an emergence of the SciKits. And that happened at a SciPy conference in 2002, roughly, 2003. And they basically said, oh, well, let's make a SciKit learn and a SciKit image. And SciKit learn became super popular. Mm-hmm. And then that was the SciKits as a concept. They first started to call themselves SciKit learn, SciKit image. Then eventually it became, why do we have this extra layer of naming convention when we can just pick whatever name we want? And then just have different open source projects that are then just collaborating in terms of, oh, we'll use a similar documentation style or a similar pattern. And so that was the community I was deeply in the middle of from about 2000 until, and I'm still in it, but really active from about 2000 to 2013 timeframe.
13 years.
That's independent of the Python community, right? And so then I kind of at about the time the SciPy was released, the pressure came. So then that was the SciPy story, and SciPy came before NumPy. A lot of people don't realize that. That my baby was SciPy, and that was this thing I was trying to make happen, is make Python able to be used for scientists to do their work and publish their work, and have something that they didn't have to rely on a proprietary language for. I'm not against proprietary code at all. I'm not. I'm actually, I think there's space for selling software, but I didn't want scientists who are publishing their work. That needs to be a place. It's a commons. There's an open technology commons that needs to exist, and science producing papers should exist in that space. And as a scientist, I didn't want to have my scientific work be published and then a consumer of that come in and say, oh, to use this, you've got to buy this proprietary package before you can even understand my science. Like, the science should be reproducible from, I didn't want that behind licensing and IP barriers, right? So I'm very much for open science, open production. I'm not a big fan of actually I understand journals, they have to be funded too, but I want papers to be available, easily accessible. So that was really what drove me in this direction, was the desire to be a scientist and share. And then I started to do that with software. And then I learned a ton about how software works generally beyond just doing scientific software. But that journey was because of my association with the Python community. Because I was a young scientist writing scientific research code, essentially, and then maybe some libraries, then learning about, data structures and packaging systems and algorithms and high-level, compilers. That came later. And when I became what I would call one of the ambassadors for science to the Python community. Some of the early ones were Conrad Hinson, Jim Huguenin, Paul Dubois. They were the ones who helped Guido add key features to the language. And so I go into this in the documentary. I don't know how much of it's going to be in the documentary when it comes out, but
sure.
I talk a lot about that, about how critical it was for those early science ambassadors to the Python community to have a voice, to be able to be heard. Because Guido's he didn't always know why. He wasn't himself deeply involved in scientific computing, but he was open to hearing the input. He was open to changing things like, let's add extended slice syntax. Let's add tuples can be constructed without formally creating the parentheses. You can create a tuple without just having the parentheses sitting there. And that was really critical for multi-index selection. And extended stride syntax enabled you to skip. If you had a big array, you wanted to skip elements evenly, you could represent that simply. Things like complex numbers. Like a lot of languages, they just say, complex numbers are implementation detail. Now, the problem is complex numbers are everywhere in science and engineering. They're so fundamental that, really when they're in the language, it matters. Otherwise, you end up with 15 competing implementations of them and nobody can agree. So having them in the language meant that they were there from the beginning. So I likely wouldn't have adopted Python if complex numbers hadn't been there. And as I looked into it, how did that happen? It was Conrad Hinson, specifically, like him and other people who joined in the community and said, lovely language here, but we need a complex type. And then back and forth conversations with Guido said, well, what letter do we pick for the complex representation, I or J, right? And the engineers won with the J. So, those early conversations were that was possible by what I'm calling scientific ambassadors to the Python ecosystem.
Yeah.
And there's actually been very few of them, unfortunately. We need more, honestly. I played a role. Nathan, we had the matrix operator added finally. That was a missing element for many, many years. So that's a bit of drama around how did matrix operator get added. And Nathaniel Smith made that happen, right? And he was as an ambassador.
What do you do? I learned a ton. Sneak into the repo at night and slip it in there? Or
well, no, exactly. He didn't. So I'll tell you how it works. You have to actually go into these communities, whether it's a Discord channel, a public discuss channel now. You spend hours basically talking to people, helping them understand why it's important, answering their questions, because a lot of them are coming from a space of, I don't know why this is important, and then so therefore I'm negative about it.
Yeah.
Right. And as the language matures, of course, it gets harder and harder. Early on, the affect was, I don't know about this, but I'm I'm a +0. So Python, this sort of story of -1, -0, +0, +1 emerged. The early community said, okay, here's how we're going to vote on things, right? +1 or -1, but you can also do a +0, -0, which is kind of, I don't really care, but I'm leaning one way or the other. To help differentiate the different ways people might feel about it.
That's interesting.
It is actually it's very useful.
Yeah, I like that.
And a lot of people use that actually to help kind of navigate this. A lot of people are paying attention, a lot of bike shed people, but like, who really cares?
Right.
Like, if you don't really care, why are we listening to your voice? Right? Because you're there.
+0. Yeah.
Okay, well, +0, great. That's good to know. But okay, let's figure out the +1s versus the -1s. Understand that dichotomy and see if there actually is a compromise somewhere. Maybe it's a misunderstanding. A lot of times it absolutely is. A lot of times it's a misunderstanding. We get so deep in our awareness of something that it's hard to be aware of another thing. I personally experienced that as a scientific ambassador coming to the Python ecosystem and getting some PEPs accepted. So I became a Python core contributor by adding some Python enhancement proposals and going through that work on a few fundamental cases. And that was great. It was exhilarating. It was also difficult, right? Because I was dealing with really smart people with knowledge in areas I was weaker in, and I had to understand where they're coming from and then respond so they would listen and then understand how they needed to be communicated with, so they would understand where I'm coming from, right? And we got so one of the things about NumPy, so that's how I got involved. And then 2004, 2005 timeframe. So this was the state of the world until 2004, 2005 with SciPy on top of numeric with a bunch of libraries people are installing. Usually installation meant either build it yourself with a tarball or rely on a guy named Christopher Golke, who was handling, like at that point, probably several hundred windows.exe files on his own personal page. So there was no PyPI, there was no, like, if you wanted to install this stuff, you got the source code, you built from scratch yourself, or you installed from this exe page. And one time, this is about 2000, when did we have this conversation? 2013, 2012, 2013. I talked to Guido at a PyCon, and I was kind of just saying, so, okay, the packaging story, like, it's really bad, right? Like, and he goes, yeah, I don't really care about it. Like, it's not something he really worried about or thought about until later he did. But at the time, he was like, oh, if I have a project package I need, I just put it in the standard library. If it's something I care about.
That's got to be nice.
Yeah, it's kind of like, well, yeah, exactly. That doesn't really work for everybody. So anyway, that's kind of illustrative of part of the problem is that wasn't sort of tackled from the beginning. And we had a lot of challenges in trying to just, we have this great language for getting the head of the person who just wants to solve a problem, and then they can think about their problem instead of the syntax, and super extensible. Like, I can actually take Fortran code and make it accessible in Python very quickly. In fact, a guy named Piero Peterson, who collaborated with me on SciPy, he wrote a tool called f2py. f2py would take Fortran code, analyze it, and automatically create the Python extension to allow that Fortran code to be called from Python easily. So he took what I was doing manually, because I was basically manually doing that on a bunch of Fortran code. And he looked and said, what are you doing? That's idiotic. And he basically built a tool to do that automatically.
Nice.
So he's far more of a computer developer than I am. I feel like I'm an integrator, an implementer, an agitator, perhaps. Someone who can try to facilitate. And that's why it led to me doing more entrepreneurial activity than development activity over my career. But anyway, that's the story of SciPy. We can get into NumPy if you'd like, or if you have questions about the SciPy story and the ambassador to Python and the kind of how did Python become a space where science is welcome.
I kind of have a question that may not be directly related to Python, but more of the era, because Python and Ruby kind of came out roughly in the same space.
Yes, they did.
And you said that you came for the language and stay for the community. And I think that Ruby is just as welcoming as Python has been to me personally. And I'm kind of curious. I've always been kind of curious why science-related folks gravitated towards Python, the language, and then even the community, versus Ruby, because
that's a great question.
Both perfectly capable.
Yeah, that's a great question. A lot of this is timing. I think, like, I found about Ruby later, after had already invested some in creating the SciPy ecosystem, right? So, and then new people essentially are just, well, what's there already, right? And like I said, I was there when numeric already existed. With Ruby, where is the numeric Ruby? right? Who wrote that? Who wrote a numeric Ruby? Ruby had a really, really good community around web apps, and their Ruby on Rails, for example, phenomenal story for building, quality. In fact, they're way ahead of the Python community in terms of helping people build quality web applications on a Ruby backend.
Mm-hmm.
But where there was no numeric Ruby, or if there was, it was very nascent. And so it's kind of that critical mass question. And I think part of it also was the language. I mean, Ruby had it was in Japan, a lot in Japan, right? And I don't remember the name exactly, but Mats.
All I know is Mats. That's all.
Mats.
Mats.
Yeah, I just call him Mats.
M-A-T-Z,
right?
Mats.
Perfect. Mats. Yes, that's what I remember. So he was really really talented. Then the community in the United States around Ruby was in a couple of companies, right? But they're like this. I think what happened with Python is Python, because of this early cooperation impact from the Conrad Hinson, the Jim Huguenin, the Paul Dubois, the David Asher, like that's what was needed for Ruby to really get that critical mass. And it just didn't happen for some reason or another. I don't know. Maybe it did. Maybe those people got tired quickly, because it's kind of people in academic settings that were able to pull that off. Like, who's going to do this, right? It's going to be someone like me, who's a grad student at the Mayo Clinic, who's got more time than money, and and then kind of ambition than sense to try to do stuff myself. And there were people like me too. Eric Jones, a grad student at Duke University. Piara Peterson was a academic. So it's kind of that academic mindset. Ruby did a good job of attracting the scripting, the web app builder, but didn't appeal to the science mind. Syntax is part of it. I think what appealed to us in the Python side is it didn't have extraneous syntax. There's all this white space arguments, right? Well, the white space argument appealed to the scientists, right? Just putting braces where you didn't need them, putting extra line noise, that principle that Guido had, it really made a difference for people like me, right? Who were like, I don't want this extra line noise, partly because of maybe the PTSD from the Perl experience. Perl had all kinds of special characters. You couldn't remember what they did. Now, Ruby's better for sure. But I think that's a big part of it. But honestly, I think the question would be, why didn't the numeric Ruby get written? Right? Because that's what was there in 1994, 95. Or does Ruby have complex numbers? Like, I don't think it does, last I checked. Right? And a lot of computer scientists go, yeah, who cares about complex numbers? And that's typically what happens. You get computer science building a language, and then the scientist comes in, cool, can we add complex numbers? And they go, you do it. That's on your own. It's like, well, okay, thanks. And then 15 people do it. And then there's like, okay, which one am I using? Who knows? Like, there's an aspect of leadership from the center that is required to ensure that certain things get rooted. Now, I can put a laundry list of things that didn't happen in the Python community that I wish would have, that would have helped it even further. Packaging being one of them. Yeah. Like having a really strong packaging story that's led from the early community instead of like an afterthought later. I think macro, a way to not execute code, like to pass on, a backtick operator or something that lets you put code that is not immediately executed, like delayed execution on code blocks. With Python, you can only do that if you use like the with operator, or you have to write a class, you're at a function. Like, just being able to do that in line would have really helped in a lot of ways, a lot of places. And then I would love to see extended slice syntax available to be used as an argument to a function instead of only within the list operator. Anyway, sorry, that's just top of the head.
Requests, yeah.
A couple of feature requests that are really hard now to get in because you got such a massive community.
Yeah, you got to convince a lot of people.
Yeah, I got to convince a lot of people.
I looked it up while you were talking. Ruby has complex numbers, but not until 2007. So back when you were getting involved.
There you go. Yeah.
So a little bit late to that particular game, and probably because there wasn't demand for it. I mean, a lot of times you just build what people are asking for or what you personally need. You're not going to go out and say, you know what, this needs is something I don't care about, So
Correct.
You need the people to show up and say, we want complex numbers. Then, Guido says, okay, let's
exactly. Do it. So it's a bit of a random walk. That's what I'm
I mean, you don't know what's going to be important, right?
That's why I say, look, it's because Conrad Hinson showed up and found the language and said, yeah, I want this, and started to participate. And that wasn't driven by, like, nobody budgeted for that, nobody articulated that Conrad did, right?
Yeah.
And then other people like that, Paul Dubois got involved. Then Jim Huguenin, as a grad student, he was a master's degree student at MIT. He saw the matrix sig. He saw someone built a matrix.py in Python. He said, I I'll try my hand at building an array object in Python. And he did. He wrote and it was good. It was like a really nice array object with multidimensional arrays and some compute infrastructure. And he pushed that out there in 94. And that was the foundation so that's what I would say. Where was the Jim Hugonin?
Mm-hmm.
And then later I came in and I felt like, I definitely added a lot, but I wasn't even been there if it hadn't been for Jim Hugonin and some of these early people that have come on before me.
Things
Snowballs. Exactly. Yeah. NumPy came about because numeric was there, and SciPy was like, that was my baby. I wanted SciPy to get usage and adoption and people, and more because I wanted collaborators. Right? It wasn't so much the users I cared about as I wanted collaborators. I liked my people to jump in and help build some really good computing tools. I really got into loving the numeric computing, like solving science problems with computers well. Right, that was a thing I really enjoyed. So I want collaborators. That was for me the driver. It was collaborators I could lean on. And then the Space Telescope Institute, Hubble, the people that shipped Hubble, they were starting to use Python, and they're using numeric, and they're using SciPy modules. And they thought, how do I need a better array. They needed a better array, an array with more types, an array that handled memory a little better, was faster in certain circumstances. They had a couple of needs, right? And we were talking about that early as 2000.
Mm-hmm.
Right. And so fast forward 2 years, they started work on a project called NumArray. And they started to sponsor a project called NumArray, and they started to build it, and they started to release it, probably 2003, 2004. So NumArray, and it had some really good features. It was nice. It did some things that were better than numeric did. And that's fine. Okay, you could use it optionally. And then somebody released a medical imaging library called NDImage that had, and I was jealous. Basically, they released NDImage and it worked for NumArray, right? And so NDImage had something called morphology, and then n-dimensional convolution. They did a great job of implementing it, and it did it better than the ND convolution algorithm I'd written. It was in SciPy, and so, but it used NumArray, and so now there's SciPy on numeric, and this NDImage library on NumArray. And the two communities were basically like, it was
competition.
It was competition, but it wasn't collaborative either. Like if you were using numeric, you had to copy your data over to a NumArray. Like it was, and for a scientific programmer, you end up using memory tons. Like, because a whole other stream of thought would be, what about PyPy? What about the JIT compilers? All that story, right? And we can get into that because I ended up in the middle of that later. But right now, in this point, it was, how do I actually connect these two arrays? And I have to copy it. And I'm already struggling with memory. I'm using gigabytes of memory, and I can't use another gigabyte to put in a NumArray. So it was going to split the community and cause people the interoperability not to work very well. So that's the problem I set out to solve in writing NumPy. And in 2005, I basically was a professor at BYU at the time, and I said, this is a problem, but who's going to solve it? Like, nobody's going to do this because it's complicated, and who knows enough to be able to do something like this. So there was a semester a class fell through, and so I didn't have any teaching load. And so I said, well, I'll just do this. I'll take the next 3 months and do this. Why not? I'd written a bunch of modules for SciPy. I'll do this. That was in 2005. So that's where NumPy came from. And a big part of the strategy was actually, well, how am I going to get adoption? Well, let me go talk to Guido. Maybe we make NumPy and we put it into Python. So I started to talk to Guido around that time, around 2005, about how do we make the Python community more aware of the NumPy ecosystem, and maybe by putting NumPy into Python itself. And I met with him about 2005. We talked about it, decided against it initially, but that is where the idea of the buffer protocol and the memory view object came. So the memory view object and the extended buffer protocol, there was one already. We made a better one. That came because of those conversations. And I would say we got the data structure of NumPy into Python, if not the library, right? So that was and that's how I became like this deep embedded ambassador for a few years, probably about 7 years. I did that for a while.
Did that solve the problem of this division and this competition?
Yes, it solved the problem. It absolutely solved the problem. So NumPy was wildly successful, way more successful than I thought it would be, honestly. It blew me away. It was work, and I actually ended up losing my tenure track position at university because I spent too much time on NumPy.
Oh, really?
Yeah.
Now I know why you're an entrepreneur now.
That's what exactly. No, there's a deeper story to that, but it depends on which version of the story you want to hear. It's all, the little sound bites, you never get to the full story, but it definitely had an impact on my academic career. So, but it was okay. It was okay. It was something I really
Python
wanted to
martyr. You're a Python
martyr. Exactly. Exactly. Hey, if that helps people launch their careers, fine. Right. Now what I do is I try to say, look, if I can be helpful to you to build a company, to build a Python organization, to build a project, I would love to help. Let me know, because I've been so benefiting from other people as well. I want to help you do the same thing. Let me know if I can help. And that's what I do now, right? So it's a long history of all kinds of stories. You can see there's all kinds of avenues and places where you can literally, you could have like a Netflix series.
Yeah, totally. There's lots of different ways to go.
With the right writers who can bring in the drama, because there's drama, there's people, and there's conflict, and there's disagreements, and there's, I don't know if there's any love interests. I don't think we've had enough romance, actually.
Well, you can always write that into the script.
You can write that into the script.
Based on a true story doesn't mean it is a true story. Right. You got lots of liberty.
I mean, I've had romance. I've got I've got a wife, and we've been married 30 years. We have a great time.
Oh, congrats! That's a long time.
Yeah.
So that's a bit of the scientific side of Python.
Yes.
Your subgenre, so to speak, and its rise to prominence, or why so many people adopted Python. Because the early adopters came. They laid the groundwork. People like you came after them, built tooling. Really, it was like this has the tools I need. It's a nice language, and it grows and it establishes, and like people just start to choose it. What about like the industry side? Like, why did Python grow through industry? My only guess is like because Google used it, and like people wanted to work for Google.
That's a great question. It has this similar multifaceted story narrative that also coincides with individuals using it. And those individuals then go get hired by the companies. So one of the very first was Google, because Google started to, very early on, they used Python as kind of this is a way for us to find great developers, because the only people using Python are people who care enough to go and do this on their own. And so they kind of use it as a selection filter to find great developers. And then early on, okay, you're here, all right, you want to use some Python, okay. And they started to use some Python internally. But it was more because of the people they pulled in who wanted to help Python grow.
Gotcha.
But they built it. They've used it quite a bit. But lots of languages are supported inside of Google, right? They've supported lots of this open source growth. I think initially it was the people that drove it, and then like my experience personally has been in the financial industry and in the scientific use of coding industry, where they were trying to solve problems, and the scientists need to solve a problem. One character, for example, is a guy named Karat Singh, who had made the rounds between Goldman Sachs and then JP Morgan and then Bank of America until they went to his own company. And every time he was basically trying to build a system for derivatives management. And many people will understand and know a little bit at least about the derivatives empire, the fact that we have these underlying equities, then you have derivatives on them, and the derivatives value could balloon up, and it led to the 2008 crisis, all that stuff. Well, about 2008, suddenly that's when all the investment banks said, we got to get our handle around this. And so there was requirements to build a system that would manage their risk assessment or their understanding where they are. And Karat Singh was there helping them build that. And he went, let me just use Python rather than Goldman Sachs invented their own language. In fact, if Goldman Sachs had actually released their language as open source back in 92 or 93 when they built it, we might all be using slang, right? Because they had something pretty good inside of Goldman Sachs way back then.
It's called Slang.
They didn't release it. It's called Slang. Slang and SecDB is a database. And
never heard of it.
No, exactly. Neither does anybody else.
Yeah, they should have released it.
You might have if they had released this open source. It's actually a good story to enterprise. And so enterprise is starting to learn that story, right? This is also part of why I think companies start to come to Python, because companies, so part of it is just the developers, then part of it is companies realizing that they need to rely on these open source projects. There's been building dependencies on it, and they should start participating in it, right? And how do they do that? And I think that journey is still with us. I think companies haven't figured that out yet. And that's one area that I love to talk to people about, because I think I have some insight, having seen so many things in this direction, both inside of big companies as well as part of big communities that are there. There's some, okay, where's the friction and where's the real opportunity? But these financial community, they all start to build these tools around Python, right? Because really of these key connector people, again, kind of, and people have written books about this. The Mavens, I think, is the book that is the word they use to these key connectors, these influencers, like call it technology influencers.
Yeah.
And it's kind of, it's people that do a bunch of work. And then because they do the work, other people go, cool, you've done the work, I'll use it. Okay, right? And so then they build from there. It's how open source is diffused throughout the world. But companies started to rely on it for risk assessments. And risk assessment is mathy. Like there's a bunch of simulation, there's a bunch of array math you're doing. And so all of that leveraged the NumPy, SciPy, and related ecosystems that were emerging. Pandas. So Wes McKinney was at AQR, one of the hedge funds that was heavily reliant on Python. He and every single other hedge fund heavily relied on Python, built their own data frame object or something like a data frame object themselves. Wes McKinney was able to convince AQR to let him open source it. And then he spent further time in 2011, 2014 shepherding that early release to make Pandas what it is, right? So, and he was a friend, connection, part of the SciPy community. We knew him. He was doing this thing. There were other libraries that are also similar for a while, but Pandas ended up dominating because of his effort and influence. But lots of other companies now are going, darn, we got to convert internally to Pandas. Because of that same issue. Like, so companies have learned, either I open source what I'm relying on, or I risk technical debt of having a code base to maintain that nobody cares about. And the new people are coming in with on a different infrastructure, different story.
Right.
So that's something I think has happened with the AI world. And I know specifically what happened in the AI world because of TensorFlow and PyTorch. And then in 2018, when I left Anaconda, which is a company I founded to help make packaging work better and then other data science better, actually. Basically, I saw, oh my goodness, I wrote NumPy to bring the array communities together. And 2018, there were literally 20 others. But they're all around this AI story. There's MXNet, there's PyTorch, there's Torch, there's TensorFlow, there's so many of these other array libraries effectively. Now, fortunately, we'd fixed it twice in NumPy. Not only do I create NumPy, the array library, but also create a buffer protocol so that even if new array libraries existed and showed up, you could still share data. Okay. Right? So there's a fix it twice concept. And then that's what we did get in there so that, okay, great, there are all these different array libraries, but at least you can share data now. You don't have to copy data from one to another. Right? So that's at least a saving grace, but they're all over the place. And each one of these companies, they did it, primarily they wrote, like PyTorch started as a Lua library. There's a C++ Lua library, and there's 3 versions of it. TensorFlow is a C++ library called Disbelief. Each of these have their own internal organizational C++ stories. They started to launch them in 2015 timeframe, 2014, 13, 14, 15, started to put these libraries out there. People started to use it. Well, at this time, there'd already been 13 years the SciPy ecosystem and the SciPy conference. And a lot of academics, and the very first machine learning library, Theano, was right in the middle of the SciPy ecosystem. So a lot of these first early array these early papers on machine learning were Python based. And so when these big companies came and shipped their libraries, the community said, where's your Python interfaces? And demanded the Python interfaces. And then, okay. I mean, I've heard this story specifically from several of these people inside these organizations. So then they went back, okay, and they built the Python interface. Sometimes badly, TensorFlow, sometimes better. TensorFlow fixed their problem by buying Keras. Keras was a good interface. And so that's the interface for TensorFlow now that's great. But PyTorch from the beginning, because they were in the research lab, they from the beginning tried to build community around what they were doing. And so because they did that, they were actually able to get more scientific embedding. So a lot of this is how a company goes about doing open source matters a lot in terms of its longevity and how it's going to be, what I think who's going to win. You can predict based on how they're approaching the open source ecosystem. And PyTorch did a better job than TensorFlow, even though Google invested in a group to try to make that happen. But the problem is it's not just having a few people do some podcasts and do some DevRel. It's actually how are you managing it internally? Like, what is your story internally? Like, do you on the Meta side, they had PyTorch as a public thing, and then they had the Meta application of PyTorch that was separate. On Google, the difference between the TensorFlow development and their internal usage of TensorFlow was not very separate. So they really couldn't open TensorFlow to wide scale, input because they depended on it heavily. And therefore they couldn't just allow, some random pull request from a community upset their own internal usage. So you have to manage that. You have to manage if you're going to be serious about engaging with others in your open source community, you have to put a bit of separation between your community-driven sponsorship or community engagement and your internal development processes. If you don't, you're not gonna be able to manage it. Some version of Conway's law, where the software resembles the organization. The corollary of that is if your organization relies on the software structure, you're going to hurt your organization, because you can't have your development teams and your delivery teams dependent on a random pull request from somebody in Estonia that isn't working for you. Like, that has no
right.
You have no way to kind of hold them accountable other than just stop using their code. So anyway, there's a lot to be said about that. Actually, as corporations start adopting open source, this is not well understood by the open source communities often, or it's better understood by the internal development teams because they have to. But open source communities sometimes don't understand that, and then they get a little confused by corporate actions. They make the wrong assumptions about what companies are doing and why. And that can lead to some friction, misunderstandings, and people feeling like they shouldn't support something because they're reading into a corporate behavior, a corporate action that isn't true. It's just a consequence and the lack of a PR statement, right, from somebody in the organization. Anyway, that's a whole other topic, but I often get involved in conversations like that with the corporate side. But the open source community side, it's just a massive ecosystem, and corporations adopting open source because it helps them. Actually, Zuckerberg probably said it really well most recently. I don't know how he feels about it right now with the recent AI changes. But previously he said things like, and I think is valid, by releasing open source, you can actually influence the direction of the industry's going to more align with your internal choices. So you don't have the slang moment at Goldman Sachs, or the pandas moment at any number of unnamed hedge funds that had to adopt pandas instead of their own data frame, because they actually recognized open source the way to align industry to your roadmap.
That's certainly one way to contribute, for sure. I mean, if you're that far ahead to be a leader, I think a good example was probably like Borg and Google and Kubernetes. Borg was great internally, but didn't make sense externally because Google is Google, right? But Kubernetes, an orchestrator engine, made a ton of sense, and the whole story is different now because of that.
Yeah, and actually Kubernetes, great point, because I actually knew the person who was in charge of both TensorFlow and Kubernetes at the time, and they wanted to kind of figure out how to, get community involvement in this too. Kubernetes succeeded, TensorFlow did not in that regard. And I think you bring up a great point. And part of it was because they didn't really depend on Kubernetes internally. Right? It was just a thing that came out of their story, whereas they did depend on TensorFlow.
Yeah. Is part of what you're saying, and maybe this isn't the point of this conversation in a grand scale, but it's part of what you're saying is when corporate control permeates into the development life cycles of the software, it begins to mimic what the corporations want versus what the community and the technological folks need.
Yes. It's actually that juxtaposition of corporate constraints and therefore corporate control and community needs, and which is broader. It's kind of because the community needs includes other corporations, but it's basically the broader set of infrastructure needs that everybody needs, and how much of that is the corporate willing to give up for the benefit of other people contributing, right? Because why would a company do this?
Basically,
it's the 80-20 rule. Exactly. Because why a company could just do it themselves. Great, just do it yourselves. They have their own story. Who cares? And in fact, a lot of companies have often. I've given talks at organizations where they want me to talk about how do we adopt some of this open source ethos in our 100,000 developers. I mean, we have 100,000 people here, and we would love some of the energy that happens in the open source ecosystem to happen here in like a private mini, open source enclave. Just even if it's not to the full world, but at least it's inside of our company, people are more aware of it. Like, how do you do that? So we've gotten into some of those conversations about what are the incentives that drive open source. How do you mimic those inside of an organization? Can you? One of the critical things to me, and this is also why it goes back to the people stay for the community, it really comes down to respect and ownership and accountability. And do people feel that in the community? Do they feel like their voice matters? Do they feel like when they contribute, it's not just ignored, but it's heard? And then furthermore, do they do something that they feel pride in? Because like, this is the thing I built, and I show it to the world. Right. And that's what open source enables for engineers that inside of a big company doesn't happen as well. you go to get another job and you're like, cool, I did all this great work. Well, can I see it? No, it's over there on their repo. I can't show you. Whereas if it's open source, here it is. I can show it. And so a lot of developers, a lot of engineers have felt like, oh, this matters to me in my career. I need to do that. Now, what I'm finding is that that's actually some of that spirit, that energy, that ethos is not there among the new developers coming in that there used to be. And so, a lot of people new to programming are like, their GitHub repos aren't great. They haven't really contributed to open source communities. They're kind of, let me just get that job. And my advice to a young developer is go find a few open source communities you love, you get excited about, and start participating in them. Just show up, hear what the problems are, contribute something to it. Even if it's documentation, even if it's just a README for a newbie. Like everybody, if you're new, great. You have a power nobody else has in the community is you're new to it. Everybody else has been there a while. They don't know what the problems are for someone new adopting it. So great, document your journey and write a story for a new person how to make this more accessible. There's a lot you can do. Anybody can do to participate in open source and do that. Okay, maybe you can't do it 20 hours a week, but do it for 5 hours a week. Do it for an afternoon. Do it for a weekend. That'll have more impact on your career than sending out resumes. Because it just helps. There's a correlation between your participation in open source communities and your ability to contribute to a corporate community. Now, it's not one-to-one. It's not identical. And the reverse isn't always true. There are also people who struggle to participate in open source communities because it takes a bit of thick skin, a bit of, I can work remotely with people, I can communicate via text or email, and maybe you're not good at that. You're better in person. You're better at and so there are. It's not the only way, but if you can participate, it's easy.
Well, you could always just go practice that leak code problem. That's what they're doing.
Yeah, that's true. That is true.
It's like, which one do I do? I don't know.
No, I've had that conversation with someone on LinkedIn who was asking me, how do I do it? I said, well, okay. But, I can just share my experiences, right? I mean, some of my experiences might be relevant for the future and some might not. It's because things do change, but I'm happy to share my experiences, and if anything is helpful to somebody, I'm more than happy to share. I'm super eager to help people. Like, I want to see a world of more owners. I want to see a world where there's distributed opportunity to collaborate. What I've loved about the ecosystem I participated in is when people come to the table, like it's a round table. Like, I like these round tables. I understand the role of hierarchies. They're helpful for certain things, but I love when you're in a room where people feel like they can contribute, and they have something, they have skin in the game, and they have something they're trying to contribute.
I've definitely seen the decline of the GitHub resume.
Yeah,
emphasis.
I wondered about that.
I don't think it's gone. I think it's declining. Okay. But that being said, I don't actually disagree with you. I think that people should do that, but maybe do it a little bit more. I'm not saying you have applied intention, but like maybe do it for the love of the game. And I think maybe like your portfolio, your resume, whatever, could be a nice side effect of you. But actually, it's fun. It's fulfilling.
Thank you, Jared. Yes.
Pay it forward there. That really is satisfying.
Yes. And nothing I've done would have been possible if I didn't love it.
Yeah.
The only reason I did it because I loved it. It was actually something I really loved doing. I didn't know it wasn't because, I get a job if I do this.
Right.
The opposite sometimes. Like, actually, I lose my job if I do this.
Yeah, I've seen a lot of people that they're like asked about their open source work and they don't really have any. And so they think, I need to go have some. And if the goal is to like have, the green dots on your contribution graph, well, of course that can be gamed. But if your goal is like to have some open source because you need to have some open source, that's ultimately going to be empty and not very fulfilling. That's kind of the same thing. And not very impressive either, because you're like, oh, cool, I opened up a PR on some meaningless thing. And so
super well said.
If the right intentions are there and stuff, it all works out. If not, and then it is, you might as well
1,000% agree.
Code.
Yeah, 1,000% agree, Jared.
Yeah.
Yep. Very well said.
Side tangent. You were talking about all of these, the TensorFlows and the Pandas, and then like all these things that were like kind of competing or burgeoning out of in this messy way on the scientific side of Python because of machine learning needs and because of industry driving these things. And that got me thinking about Mojo. And I just wonder your opinion on Mojo, which is the Pythonic language that's like right in that wheelhouse.
Yes. No, I'm excited by this kind of innovation. right? In 2012, when was it? 2011, 2012. 2012, I started a project called NumPy. At the same time, there was a language called Julia that was emerging, and NumPy was a Python compiler that took a subset of the Python language and made machine code to make things fast. And we actually, by 2013, were targeting GPUs. So you could actually write Python code that ran faster than any C++. Like we were showing that in 2013 at the GTC conference at NVIDIA, because you could basically write Python code that would run on GPUs directly. So I love that whole space. Like this is something that it took me a while because this is when I finally learned how to write compilers. Now I wrote the first version, then quickly found other people to make it better. But I actually took a compiler class from my friend David Beasley in Chicago to try to understand, at least have something besides just what I picked up from the internet, right? And that helped me see the vision for, Python can actually be orchestrating compiler tools, and there's no reason you can't just write syntax that's Pythonic, looks Pythonic, and then have it compile the machine code. There's zero reason that can't happen. Right. So there's no reason you have to use C++ or Rust to write machine code. You can totally write a subset of Python and have very fast code. And NumPy proved that, and proved it pretty well, actually. And then since then, there's been like 20 other versions of that. Like right now, if you go to lpython.org, LPython stands for LLVM Python. It's an example of a compiler for Python, lpython.org. And a table there shows a list of other similar projects. Some of them are a little bit more like Mutica, where they're translators from Python to C++. Others are like Pythran is another one. Codon's another one that's out there. Like there are literally a dozen, all right? And so
I'm looking at the table. It's probably 24.
24, yeah. Now, so, now all of them are kind of this example of scratch your own itch, something that's that is built. NumPy has a team at Anaconda still working on it, and so it's actually received a lot of support, and so it's kept up to date with the latest releases. And there's a lot of every time the bytecode changes in Python, NumPy's got to change because it goes from the bytecode on. And you can actually write. There's also a tool called Python out there. Python was in the same, it's not exactly the same, but it was like, write it in this language, and then you can write extensions quickly. And even something like F to Pi might be considered in that category. But Python, NumPy, so I love this space, right? I would say, so Mojo is great because Christian was one of the original creators of LLVM, and NumPy depended on LLVM. Like, so I've been an LLVM fan for a long time. So I'm like, well, this is awesome. We get kind of the OG kind of bringing Python to compiled languages. Awesome. Right. What you going to do? Let's make that happen. I think what I'm hopeful for, and I know he's got funded and there's a company structure there. So some of the same concerns about, corporate capture of communities and how does that work? I don't think he's actually even had those conversations yet. I think those are, so I'm very hopeful and excited by the technology innovation that will occur. And I'm cautiously optimistic about what that might mean. I know that he wrote, I think one, very, very concretely, he transformed Objective-C to Swift, essentially, with LLVM. And so I think part of his thing, and I talked to Christian, so I know a little bit, but I don't know him 100%. But I've had a couple of conversations with him about what does he think, where's he trying to go with this. I think his experience making Objective-C users move to Swift was pretty easy. Right? Because Objective-C is kind of all Apple community. Right? Python's much, much different. Right. Like you're not going to have the same experience. You're not going to be able to take the whole Python ecosystem and move them to Mojo in maybe in a decade. You could pull that off, or billions of dollars. Like money might be able to, but that money has also got to be able to hire the right people to have the right connection points. So you're interacting with the right communities, because you can't just have great tech and then push it on people. So I'm eager, I'm open, I'm really eager to see it. But I'm okay. Is Mojo open source yet? Is it community driven? How are decisions made? And it's all early days. So I don't. These are hard things. So I'm right now. I'm of the attitude. I'm excited. I love seeing what he's going to come up with because he's a brilliant guy, and I want to see an explosion of languages that are Python-like that enable the Python ecosystem to actually make fast runtimes starting from Python syntax. I know there's a lot of enthusiasm around Rust, and I don't need to dampen that enthusiasm. I like Rust too, but I think there's far more low-hanging fruit in just having statically typed Python. In fact, I call a little project we're working on at Open Teams called, but it's very early and it's not a competitor to Mojo by any means. I call it post Python, performance optimized statically typed Python.
Okay.
And it's basically saying, oh, Python now has annotated types, optionally annotated types, right? Now, you can use them for lots of things, but if we just, with this post Python language definition spec, so post Python is about creating a spec and a definition with lots of runtime implementations. So in my ideal world, Mojo, Numba, Python, Codon, all these, and then JAX, PyTorch, these are also compiling subsets of Python. PyTorch does it directly, JAX does it directly. If these could all have, here's the syntax for a statically typed sublanguage that if you format it this way, then you can compile it, and then these become compilers. So in my world, you have a standard that allows people to, and then you have implementation of that standard. You can almost think of like SQL. So will we get there, or will Mojo become that by de facto, or will PyTorch? That's a good question. I don't know.
Yeah.
I would love to see more cooperation here. One of my concerns is these are challenging problems, and so the communities end up being siloed pretty quickly, and they don't look at each other very often. And so, because you've got, I'm just naming a few. There's many, many more that I've seen over the years, and they're all siloed, and they all don't really talk to each other. So hopefully we get cooperation between them.
Do you think VC funding is the reason, or promotes the silos, or no?
I think it's been promoting the silos primarily. I think where we've gotten the funding from the corporates have helped break them down, like the big funding, but VC funding has encouraged silos. I've actually been an outspoken critic, not that outspoken, but I am a critic of the GitHub star funding model of VCs. Right? For a while there, it was like, your GitHub, I see your GitHub here has many stars. Here's $5 million.
Right.
And the trouble with that is there is not a one-to-one GitHub repository to company mapping.
You can't just trade those in for dollars?
Yeah, no, I mean, I don't mind. And in fact, we could have another conversation. I think I've got a way to actually create a market for that, but it's not as simple as, because I have a VC fund too. I've started a VC fund, right, for this purpose of helping entrepreneurs create.
Okay.
And we've got 14 companies invested in. I've got an idea of how to actually create a marketplace where you can actually have GitHub stars be a market driving question, and investors are actually looking at, okay, this project's going to be used, great, I'll invest there, and then have that investment dollar go to support the development of the project while also having a return at some point from somewhere. Because that's the thing you got to figure out. You got to build an instrument that drives the return to the investor from the risk they took to invest in that project early. And a company is one way. Yeah, just have a company and ownership in the company, and the company sponsors it. That is. But can we do it in a way that actually allows many companies to collaborate and still have the benefit from the time that somebody spent investing on that project inure to them as the companies that rely on it develop? I think I've got an answer to that, actually. It's my BHAG, my big, hairy, audacious goal is to bring that to market in the next 5 to 10 years.
Really?
BHAG? Yeah. Can you say that again?
BHAG, big, hairy, audacious goal.
Oh, BHAG.
BHAG.
Gotcha.
It's a dumb acronym, but it's
it's
it's kind of like dreaming. It's what I'm dreaming about now. It's like, how do you actually make open source intimately connected to the growth of market of companies, and how do I make more owners? How do I contribute to making more owners? Obviously, I'm not going to do it myself, but how do I contribute to a world where there become more owners? That's one of the problems of my lifetime is our Western societies have, especially the United States, have decreased ownership. There's more and more money in fewer and fewer hands. And that's not great for society.
Adam's favorite phrase, you will have, what is it? You'll own nothing and be happy, Adam?
Yeah, you say that, Adam?
You will own nothing and be happy.
He brings that one up a lot.
No, it's true. You'll find yourself owning nothing and being happy. And okay, yeah, there's a pill you can take for that happiness, but
I mean, I would love to hear this idea. What do you think, Adam? I mean, are you sharing this idea right now, or are you just building it?
No, it's out there. It's out there, but I'm building it privately. It's but it's been incubating. The challenge is I can't. You go to FAIROSS.org. You can see the beginnings of that idea, which we started several years ago, and now we're just resting on because I know what to do, but I don't have the money. I need about $5 million, right?
Right.
So if somebody, but that $5 million can't have a bunch of strings attached that they got to basically say, here it is. I'll check back with you in 5 years, right? That's what I'm looking for.
Okay.
Is
yeah, it's not how investment work.
No, I know exactly.
I like to go on the record. I'm also looking forward for that.
Yeah, exactly. I know that's not how it works. Exactly.
Check back in 5 years.
Yeah, exactly. This is why. Well, you can check back in there. You know, we can read reports, but
I know what you mean. We're just.
But you know, it's like, you know, this is gonna like, and really for the 5 million to return money on it is going to take 5 years. It'll have impact before then, but like, you know, it's seeding an ecosystem and seeding a story. The idea is pretty simple, right? Effectively, you just have an organization that, on the one hand, works with open source communities to document their dependencies, both their dependencies on code and their dependencies on people. So essentially, I call it it's their MBIPs, their millibips table, right? And they basically, if you have a basis point, and if you do 1,000th of a basis point, you basically have 10 million units to give out for every project. And a project governance essentially gives out basis points for dependencies. Like, oh, I'm NumPy. I depend on Python a lot, so we're gonna give, you know, 40% of our cap table to Python, right? And then from the rest of it, we're going to award it to people. And you have some in reserve, and as people come in and make contributions, the governance can actually go, oh, here you go. Here's ownership. So you basically have one side helping people organize that. Like there's a specification, you stick it in the GitHub table, then it's there. And you can say, oh, this is you, the project, who decided a cap table, basically. You've constructed a capitalization table for the project, right? And it depends on the governance. It's not our decision. Now, what we can do is to drive that, is FairOSS could essentially have a default approach to doing that. So it says, well, this is what we'll use if you don't tell us what not to use. This is how we're going to do it. And then, of course, to encourage them to do that. So we're not gated by whether they participate or not. So you build that, and then to the companies, you go to companies and say, hey, you're missing from your cap table, your employee option pool, your investor group, the warrants you're giving out to partners, because this happens all the time. You're missing all the open source ecosystem from that group. And so let's get on your cap table. So we get on the ownership table of a company. And of course, you know, we can't get 1 million open source contributors on the cap table. Okay, great. We put an entity on the cap table. And the entity on the cap table represents the open source you depend on. So you have an entry on the cap table, and FairOSS maintains your dependency, like their millibips table. Like what do you depend on? Right? And it's and then as equity returns happen, which is distant usually, it's like, as a venture capitalist, I know how this works. And you basically, over time, value will flow. Now, if you want quick value, it could be maybe you're not going to give up equity. You're a mature company, equity is hard to come by, but we'll do a dividend agreement, like Anaconda's done dividend agreements. With an agreement where we'll just allow some of this to come. Our venture fund, for example, we already do this with our carried interest. Like we have carried interest, which some of you know what that is. It's the motivation for the partners to find good deals to invest in for their LPs' money, and then they get a percentage of that growth. And so our general partner, some of that carried interest already goes to fund open source, right? And so it's the same thing. We can formalize it through that process. You have all these inputs, right? You have equity deals, you have dividend deals, you have carried interest deals that are flowing through this instrument that becomes the funding source for all the open source dependencies. And then as opportunities arise, you're just streaming it out, distribution style, to the cap tables, and it flows down the cap table tree. Because, oh, you're dependent on pandas. Well, pandas looks like, oh, it's dependent on Python and NumPy, and then it flows down until you end up at the leaf nodes where there's individuals who are basically participating. So that's the basic idea. And then what I did, I tested that out with a few companies. Could I actually get these agreements? Could I get people to agree to that? And I thought I'd have to have a venture fund, actually. The whole reason I started a venture fund in 2019, because I thought I would have to go to startups and say, yes, I'll invest in your company, but you have to do this. You have to put open source on your cap table, right? Because I knew they would say yes to that deal. What I found is I actually got people to say yes without the money. They understood the problem. Yeah. And so I went, oh, okay, that's good, because, it's like regex. You use regex to solve string parsing. Now you have two problems. You have the problem I was trying to solve, and then understanding regex. Same thing with starting a venture fund. Same thing with starting a company. I started Anaconda as a company to solve the problem. How do I fund NumPy? How do I fund SciPy? How do I build this thing? So my whole life has been like, okay, here's a problem. How do I solve that problem? Here's the meta problem. Here's the next problem. How do I solve that problem? and they're just trying to learn along the way, and just try to figure out ways that are learning from other people, trying to organize. Because what drives me is I want to create a world where open source is a meaningful way to live a life. You can be an open source contributor and still pay for your kids and still have it, and that's a job. And it's meaningful. It's not just a thing you do on the weekends and nights and when your day job is doing something else. So this is why I've been thinking about this.
And FairOSS is the epicenter of this?
Yeah, it's the first version of the organization we've created to do this, right? And it's an idea of how it could be done, and we've tried it, and enough to know that I know it will work. But for it to work and to create the vision of where you can actually have investors, because eventually you can have a ticker symbol for every open source project, literally. You can have a market where, how's this open source project doing? That's going back to your stars. Your GitHub stars literally could translate to a value, a fair price, a fair market value for that open source project. And investors are looking and going, oh yeah, I want to buy some of that, right? Because they could say, I'll put in my portfolio that project because I think that's going to go somewhere. And how is it going to go? Because people are going to depend on it, and therefore enough of these agreements are in place where value will accrue because of those agreements in place. So FairOSS puts the instrument together. It's responsible for creating the instrument that connects the dots between the investor money and the open source communities.
What you need is a dependency graph versus the GitHub stars. I understand the analogy.
No, you have to have the dependency graph, but that's also what FairOSS manages is the dependency graph of those millibips tables.
But that's the evidence to show the should or should not be on the cap table, right? Like that's not a star, which is I like this or this is cool.
Correct. That's not what gets you on the cap table. What gets you on the cap table is it's just one entity. So, a company's not going to put 1,000 people on a cap table, but they might put one entity on the cap table that represents those people.
And you're saying that at some point for an open source project that may be of that caliber, they should have or might have either their own foundation representation or FairOSS is that representation.
Maybe, yeah, FairOSS could be that representation. Maybe they could do their own. Ultimately, it's a market, right? So markets are very complex with lots of parties, right? But the project itself, all they have to do is just track their millibips table. They just have to put and document and record, well, who gets what? Like who's accountable for this? It's like a thanks file, but it's like a thanks file with a number next to it, like a percentage.
Yeah, it's their own cap table.
It's their own, and they manage that. That is used to build the dependency graph that allows the flow through to happen from the entry point, which is just the company that puts FairOSS in the cap table also submits their own high level millibips table. Like, well, this is what we care about. And then FairOSS also, there's stuff around here to support that.
What you need is to be in the IRS, the tax code to make this have some serious incentive behind it, because at that point, every company would actually do it.
This is a separate question. I agree. I'm trying to avoid creating a ministry of open source. Like, yes, some of this could be facilitated with government as long as it's automatic and rule based and not bureaucratic.
Well, not even so much IRS, but like recognized by the business nature of the United States, right? Like LLC versus S Corp versus C Corp. There's a reason why companies form one of those, because they're recognized.
No, 100%. In fact, the way this would be implemented is actually through an series LLC.
Yeah.
Like, because essentially what you would end up with FairOSS doing, like what it does, it says, okay, we have an LLC representation for you, project, or your corporate, or whatever it is that's representing because some projects have one and some don't, right? And so anyway, yes, I agree with all of that. I would say to your point about the IRS, what I would love to see the United States actually as a separate thread have a sovereign wealth fund and allow deferred taxes to be paid. Instead of you have a tax, you just give a part of your equity to the sovereign wealth fund of the United States. If they could allow that to be used there's a ton of places where it's the tax code. Like, I've been looking at this a long time, and so much of the inhibitions, the problems we face are because of outdated SEC code, outdated tax code that was meant for a different time that's now stopping innovation in the business world today. There's so many lawyers, so many people get paid, so much effort is spent, essentially preserving yesterday's business infrastructure. Right. It's hard to innovate in.
And there's no legal precedence for it. Like, there hasn't been a case
to
represent it. So you can't say, oh, yes, we should or shouldn't do this, because there's no case law that represents how the courts may or may not lean in proceedings.
And so a big part of the challenge is figuring out how do you fit in that existing case law, but still do something innovative, right? Which leads to a lot of challenges. It really does. So
are you doing this?
Yeah, that's why it takes $5 million at least to get this going. We've done it already to a degree.
$5 million bucks. Let's get this money.
Well, if someone wants to buy Anaconda shares, they can buy them from me, and I got the money. So that's what I'm doing with my next tranche of Anaconda shares. So
you need some liquid, man.
I can get liquidity if someone just wants to make a bet on Anaconda, and I'm happy to share that bet with them. So just, if you hear this, contact me, and maybe you want to fund this, but you want to hedge. Great, you can own Anaconda shares. Let me take the risk. I'll do it.
Okay, so that's an option. I like that offer.
Yeah. Anyway, so that offer's out there to anybody who wants to talk.
I like this idea. Thinking about it slightly more deeply, it seems like there's a bit of a impedance mismatch between the value provided by the open source projects and the companies that they would then adopt, because you're basically relying on, you're going to be adopted by winners, and you might not be.
Yes, correct.
But you're still valuable, but just to losers. You know what I'm saying?
Yeah. Well, so, it might be. It's just one part of the funding fabric. First of all, I don't think it's the answer to everything, but it's something that should exist. And it's also the investor class. That's the part that it's not just the companies, but when I realized there's at least $100 trillion of investment money out there looking for alpha, which is like looking for return. And that's in people's retirement accounts. That's in investment accounts. It's all over the world. All that money is looking for investing. Where are they going to put it? And so a lot of times they property values go way up, stock values get way overvalued. Like you need a place for that to go. So you have that investment value. Then you have open source where innovation is happening. Because you look at the past 10 years and innovation that's occurred from AI to cloud to data.
Right.
It's open source communities that have been at the heart of that, but yet there's not great connection between the investor class and the open source community class.
Okay, so how do you bridge that? Imagine a world where FairOSS is running. Okay.
Yep.
And it's active and it's vibrant.
Yep.
And I'm an investor and I want to put 10 grand on NumPy.
Yep. Exactly.
What happens?
There's a site you go to, and it's traded on a public market. Maybe it's crypto. Maybe there's a crypto token associated with it. But that's what I was hoping, that crypto would actually help this emerge quicker onto public markets.
Yeah.
Like there should be a place you just call your broker, or you go into your own online thing and go, yeah, I want to invest in NumPy. Cool. It's a ticker symbol. You just put it there. Great. Now, at the moment, that's going to buy somebody else's position. But the project NumPy could say, you know what? We're going to make a release. We're going to authorize more of our millibips table to investors. And they funnel that up through and say, we've got now $10 million that can be purchased by new buyers. It's a kind of IPO.
Then you're buying their upside.
And you're buying their upside.
I see.
Exactly. So again, the NumPy community and FairOSS would mediate the relationship between the community that has to essentially go, yes, we're willing to take investor money, because they're the ones that have to take it and do something with it through their own governance or however they're going to do it, right? There's somebody that has to take that money. FairOSS just facilitates the connection between that and the market. And actually, that particular entity would be a different company that would be actually the broker dealer between the projects and the market.
Yeah,
because that's a separate activity. The current FairOSS organization is intended to be the arbitrator of the millibips tables, and then kind of the negotiation of the contracts with the companies, right? And then you have a broker dealer that would connect the two and make a market. Because long term, you have a marketplace. The Chicago Mercantile Exchange exists. Why? Because somebody put the idea of an option and a future out there and started selling them, right? It's just that. Like New York Stock Exchange exists because the idea of a corporation was created and then somebody started to sell them. So you make a market for it.
This dog could hunt. How much have you been able to convince these companies?
So I haven't really. So the problem when I left Anaconda, I had to build this whole other thing, and so my time has been spent building QuantSite, OpenTeams Incubator, my funds, and then OpenTeams now. And so I've been spent so much time there, but this has been in the back of my mind since about 2019, 2020. So I've had conversations on the side with multiple companies, enough to get dividend programs. Like Anaconda has a dividend program. Lots of companies are willing to the dividend program. That's an easy way to fund it. And then I've got a few conversations with funds to say, hey, here's carried interest. And then startups, I've had 100 startups willing to put FairOSS on the cap table. That's been super easy, actually. Well, it's a good question. So the highest is like 10% of their company they'll put on the cap table.
10%?
Mm-hmm.
That's a lot.
It is. And
it must not be worth very much.
We're really dedicated.
It's startup land, right? Because startup gets diluted, right? And it's like, and the argument really goes like, hey, here's a way to get, and for that, they're going to want what they want is connection to the open source communities. They want for their hiring pipeline and for improving their because a startup, your most important thing is the people you hire. So if FairOSS can provide an opportunity to hire, then it's worth that, right? So it's worth that is high. Mostly it's like 1% to 2%. It's pretty easy. And as the company matures, maybe a big company like Anaconda, it ends up being like 0.1% is all it is, right? Or 0.5%, right? But that's like, you add that up and that's a lot. Like if you actually took, and you only had, let's say, a few basis points on every company, and a lot of companies, they're putting more of that in their option pool for employees. And that's kind of where you're arguing. You're saying, okay, here's your option pool for employees. You need to recognize that there's a portion of this that you're not either taking advantage of and you're missing. And that's where I've had the best conversation with people. And they go, oh, you're right, that could help. Now, and then what they're looking for is, well, the company wants to know, well, can I connect that to feature requests? Can I figure out a way to kind of connect this to community connections or hiring and that's where we can talk about that, right? Because it could be a milestone-based vesting on that pool. There's ways to negotiate that, but that's what FairOSS does: is create the negotiation to increase the size of the instrument market. That's why I couldn't. My view is that has to develop, and then we can build the marketplace for the broker dealer, where you can actually get investors to come in. Yeah, but you have to build this before the investors will come in. Anyway, that makes sense. Anyway, that's my big, hair audacious goal, and what I'd really love to work on next.
You just need some liquidity, man.
Just need some liquidity. Yep.
Anaconda's not going public anytime soon?
Not soon, but they just had their Series C. It's actually doing really well. And they're very, it's a good example of a company. I can tell that story numerous times. A lot of people can tell that story. I, of course, have my own a version of the story. It's doing well. It's doing really well. But I don't know when it's going to go public. I'm out of that. I'm out of the loop on that. So you could ask Peter. You could ask the board. I could ask them. What I've heard is they're not really anxious to go public quickly, but they did just get Series C and got a new people. Actually, I shouldn't announce that. I'm sure they're doing very well, but I'm not authorized to say that they've had that. Anaconda is doing very well.
Anything else? This has been a wide-ranging, interesting discussion. Adam, you have any either follow-ups on FairOSS or something else before we let them go?
I'm just going to scrutinize it more. Really, I want to see it happen, but I want to scrutinize it more because I'm like.
Yeah, scrutinize. Give us feedback because it's still early, right? And so the idea was, let's get it out there, let's get talking, let's see how to adjust it.
Well, I'm easy to please with it because I want it to happen. But then if you take Jared's example where he says, "Hey, I'm a venture capitalist, I got $10,000, I want to put it on NumPy," what happens was this question. But what do I get? What is the incentive for that venture capitalist to put $10,000 on NumPy?
They get the returns that later come. So remember, if you get on the cap table, are you on a cap table? Have you been an owner of a company? If you're FairOSS has ownership of a company, but that ownership is tied to flow down through the dependencies, right? So basically FairOSS is the arbitrator helping as people use NumPy more and more. Now all of a sudden, Netflix and Amazon and OpenAI and Google, they all basically depend on NumPy in some way. And even if it's like, a millionth of a basis point of the value of that company is now flowing through FairOSS to the NumPy community. But in aggregate, it could be hundreds of millions of dollars, actually. It's sort of people have told me, people said, NumPy has had billions of dollars of impact on the economy. I'm like, great. Where do I see that? Where do I measure that? How does that show up anywhere?
For a second. So back to the venture capitalist with the $10,000 that puts on NumPy.
Well, it would probably be an investor. It probably might not be a venture capitalist. Would probably put more than $10,000. They'd probably want to put a million in early, right?
Okay. Well, pick a number.
Just tell me with the Robinhood app.
10,000. Yeah, that's later. The Robinhood app is what I want to get to, but that's going to take a little bit of time.
Totally.
But you have $10,000. You put it there. Where are you going? Well, one, you have other buyers, right? Because every market, if you think about stocks in general, why do you put money in stocks? Well, maybe they'll give a dividend someday, but no, because you're going to sell to someone else, right? So it's the same thing here. Is there a buyer for this later? And the answer is sure, if the market's real. And why would the market be real? Because there is an eventual value.
What exactly are they buying? Help me understand that.
They're buying ownership. They're buying ownership in the millibips table that NumPy is governing.
And remind me what the millibips table is. What does that consist of?
So millibips stands for a thousandth of a basis point. So there's 10,000 of them per percentage, or 100,000 per percentage point. So it's a percentage What you're buying is a percentage of the NumPy project. So, and then, okay, cool. I have a percent of the NumPy project. What does that get me? It gets you any value that flows from the FairOSS infrastructure to that project. So let's say in the future, $100 million is flowing to NumPy from companies whose value either FairOSS sells the position it has and flows it through, or it earns dividends, or there's numerous ways FairOSS is creating actual transactions with the market that flows money back to the open source community. Okay. So it's aggregating that, and then downstream, some of that aggregation is coming to the NumPy project. And as an investor, you have a right to a percentage of that.
Okay.
That's what you're buying. It's like buying a stock in a company. It's the same thing.
Yeah,
why do you buy stock in a company?
Now.
I'm tracking. Why do you buy stock in a company? But we've had to create the instrument to enable the flow to happen. And so an investor could see, because that's what investors are going to see. Before the market can develop, investors would have to look and say, okay, wait a minute, how is this going to work? And so that's what it takes work to develop that market. It takes work to develop the relationships with the companies, the flow through from their value to the rest of the market, and then the aggregation. And it's a technology problem. There's stuff to do, because you basically have, there's like 5 million open source projects. I kind of think about 500,000 or a million of them are probably, so you're going to have to onboard them. FairOSS will have, okay, we have 10,000 projects we're supporting. Now it's 100,000 projects we're supporting. It's going to be a pipeline there. And the same time, FairOSS is going to have to build, we've got 1,000 companies participating. Now we've got 10,000 companies participating. Now we've got 100,000 companies participating. The market's growing in both directions, right?
You got to build both sides. So
both sides.
Which side do you build first?
It's a combination. Like you have to do both. Kind of, it's like every bootstrap problem. You have to attack both at the same time. Mm-hmm. And so it takes work, and it takes a lot of conversation, selling, communication, trust building.
Let me be more clear with Jared's question. What is the most clearest form of a good next step to make this happen?
For me is the money, because I already spent as much as I could. I've probably spent about somewhere between $500,000 and $1 million on this already. Just from the consulting company I had, and we were just taking from, money we didn't send back to our investors, instead invested in this idea. So we've taken money already to invest, but hiring people, because I hired people and they did work on some things, and it takes resources to do that. So the next step is that money. That's why for me the next step is to get that pocket of money. And 5 million is kind of, really 2 million is like the minimum, but I'd like 500K to invest in this company for 10 years. That's why 5 million. Because I want it's got to be funded so that there's people who are hired to pay attention to this problem and are working towards it. And I want it for 10 years, because this is not something that's going to be solved in 3 months or 6 months. Yeah. It's something that will need time to develop.
And the company is the FairOSS company.
FairOSS company. Yeah, it's investing in FairOSS. And why will it be valuable someday? Well, it's the broker-dealer ultimately that will create value for FairOSS. That's why FairOSS itself is a public benefit corporation, because I don't know if it's going to have value or not. Its purpose is a public benefit. It's to build the market of open source. And so whether it has value intrinsically or not, who knows? But the broker-dealer will at some point, because it'll be the same reason it's a transactional, right? It's there basically brokering conversation with investors and their money.
These public benefit corporations, remind me of the structure of that. Is that a C Corp that has a different classification?
Yeah, correct. It's a designation. And there's a few different versions of this. The public benefit corporation is in Delaware. You can basically tell in the articles of formation, this is a public benefit corporation, which means you've told the Secretary of State, as well as every other investor who might invest in this company exists not only to maximize shareholder value, but to also achieve some public benefit. So you can't a shareholder can't, invest in the company and later come back and say, hey, you didn't have a fiduciary responsibility to me in maximizing my investment, which is kind of the default corporate law. They go, well, actually, you have to prove that we weren't supporting the public benefit that was told you from the very beginning. That was in the corporate charter. So it's an innovation. I like it a lot. It's actually a really good innovation, because even companies that don't have it, they still benefit the public. Like a lot of people have the idea that somehow corporations are somehow inherently evil. They're not. They're just an organization to kind of pool money together so you can do stuff.
Their motivation is different than a human. That's the problem.
They're motivated, and it definitely is true. Definitely is true. There's an agency
they're capitalistic by nature. I mean, by design. It's the whole point. They're capitalistic by nature.
Yeah, exactly. That's their focus. So the public benefit corporation allows you to insert an incentive structure into communication. So every shareholder goes, and then management, you hire management, and management can go, oh, we're attuned to this public benefit, not just maximizing shareholder value, right? It's actually this public benefit too. And so it's a nice innovation. There's also something called a B Corp. A B Corp is a different thing. You could have both. A B Corp is you get a license from a firm. So a B Corp is a branding thing. You basically pay a fee and get a license from a firm, and the firm has ways you can show that you're a benefit corporation. Whereas a public benefit corp is just an institutional infrastructure thing. You publish, you record in the state of Delaware is where I've done it. Other states you can do it too. That's the thing about corporations; they're state by state. Delaware is just the closest thing we have to kind of a, everybody, a commonplace. People do it, but that's what it is. It's a public benefit corp, and several companies have been doing this, particularly around open source, because people go, wait. As open source contributors realize, okay, how do we use the mechanisms of institutional capitalism to support our mission? And that's what I like to do. I don't call myself a capitalist, but I definitely am I like people, and I like distributed ownership, and I like people to be able to be free to work with each other, and I like decentralization. So I'm just like, how do we use this infrastructure to further the means of our open source desires? And so that's at the heart of what's basically driven me for the past 20 years, basically. And, had some success, but some failures, and I'm still trying, right? Still working at it, and then trying to find other collaborators, other people that are similarly interested. And, Open Teams is the latest one that's launching right now. Anaconda was with them first. I did some consultancies before that. I've done some consultancies as well. And then I've talked to a lot of people, and I'm very eager to collaborate with anybody else thinking along these lines. Because honestly, this is something I would love just to exist. I'm like you, Adam, basically. I'd love it to exist. So, okay, well, kind of like NumPy. I'd love it to exist. Well, nobody else is doing it. Maybe I should do it. Kind of the same way. Okay, I'd love it to exist. Nobody else is doing it. Maybe I should do it. And we'll see.
Okay, so I got to imagine that as part of this, we'll drum up some interest to some degree.
Okay,
we do have
great.
some
Contact me.
variants of influence. So you need roughly $5 million to fund FairOSS, and that
for the next 10 years.
For the next 10 years, so $500,000.
It'll need more than that, but that's enough to make sure. That's enough to make sure that we can hire people, because I'm going to allocate and I'm going to hire people and I'm committed to people, and then it'll self-fund.
And you'll hire some people to bring on projects. You'll have let's say 10 or 20 or 100 of your initial pool of projects that will, show off there. What did you call it again? This table, the MIPS. What was it called?
Millibips.
The millibips tables. Yeah, there's a tech part of this.
Is there a different name for that? Gosh,
yeah, please come up with one. Yeah.
I do like it. It's just forgettable.
Yeah, I hear you.
And easy to confuse with something else.
Yeah, fair enough.
I like the idea though, because you're selling access to this table, which is not truly ownership in the project, but future value it can create.
It's future value it creates, and so it's a separate file. Like you have the thanks file, it's separate and it's the responsibility of the governance team to update it. Like FairOSS, when it onboards a company, will have one, right? And basically we're like, okay, here's the table we're going to use for your project, and who gets to, and you can change it anytime. The governance of that project gets to change it.
Well, I think it's more important then, right? I mean, it puts a heck of a lot more importance on
it does,
just
right?
willy-nilly open source.
It does, and that's also, I'm aware of that. So I'm also like, because I also seen projects when money starts to get involved, culture can change very quickly.
Yeah, I mean, motivations totally change. I mean, it can. If I feel like I put my work out there and somebody else is getting the dollars from my work, I'm feeling.
Then you're going to create. Then you're going to be upset.
Show up. Yeah,
exactly. That's actually why I feel like FairOSS is going to need to have like almost like an ombudsman office, right? Whose whole purpose is to help resolve disputes between governance questions.
It also feels like a license too. FairOSS reminds me of like the license movement.
Yeah, that's why we kind of have a groundwater. Exactly. If you look at the site, we've got the groundwater program. Like it's like you have this idea and then you get a label. So the project could say, I'm participating in this groundwater program. And then companies could also say, I'm participating as a means to attract developers. Because for companies who participated, they're basically like, why did they do it? Well, they want to hire great developers, and they see there's a way to do that. They recognize the problem of they're going to bit dependencies on open source they can't maintain. And they want to figure out a way to pay ahead for that, or figure out how can I reliably rely on an open source ecosystem when that old XKCD graphic of the dependency that's in the middle, it disappears. Then what? Like, a lot of companies are realizing this is a problem. So there's more to do there. Like, this is it's why I say it's gonna take effort and consistent effort and the right kind of people. Like, I'll have to have DevRels. I want to hire ambassadors. There's all the people involved in open source for multiple cycles. I want them to tell their stories and to come and talk about it. And then there's a podcast that I'll have to promote. I mean, there's lots of things to develop here. But my perspective is, if and when Anaconda actually becomes not just paper value, but real money, what am I going to do with that? Build this, right? Build a way to give back to everybody else.
It's got a shot. I think.
Well, I appreciate that, Jared, Adam. That's kind of you. Yeah.
It reminds me a little bit of the tea.xyz conversation we had, but not like exactly one-to-one, but similar in nature and its
similar nature. I've seen a few emerge. I spoke to him, yes. And that's what's excited me recently is I've seen a couple of these. We're like, oh, okay, we're onto something here. You guys have a similar concept, and I would be happy to join forces with some of these folks too. Like, this is not there is zero desire to be the only founder. Like, I've been a founder, I know what that is, and I'm fine doing it, but I'm doing this to support a concept. And if there's other people that want to take I'm happy to be a spokesman. I'm happy to just be somebody that promotes it and that negotiates people and encourages them why. And I'd love other people to own it.
I'm going back through our chapter markers, and when we're talking to Max, we talked to Max end of last year at All Things Open. We got All Things Open every year. Big shout out to All Things Open.
Yeah.
Love
great
that conference.
Group.
Love everybody
anybody there. I would love to talk to people there too, because I did talk to T, and I think they were the closest of the ones I've seen. I need to revisit that again.
Yeah.
But that's actually who I'd love to talk to. Like, collaboration is key to this.
I don't know what my idea was, but at 1 hour and 12 minutes of that conversation, it says Adam shares an idea. I don't know what the idea was. It may have been a really terrible idea.
No,
in all honesty.
I'm sure it had a lot of signal.
Find out. Yeah.
I would go back and listen to that, and I would definitely circle back with Max, because you got similar desires, different implementations, but similar desires. Very much.
I will. Thanks for reminding me about that. I will, because I do remember. I will. Thank you for that lead. Again, that reminder. You guys are great. I think what you do is actually very valuable, because it gets people talking and then listening and reaching out to each other.
We listen a lot. We talk very little sometimes a lot. Sometimes I share ideas that are bad, apparently. We'll see if it is good or not.
The chapter title did not say Adam shares a bad idea.
Yeah, that's true. If it was
I'm pretty sure I wrote that chapter title, and I would have put that in there if I thought the idea was bad. So
okay, it was a good idea. Jared liked it then.
It was a great idea. Yeah.
I mean, we care about funding open source, and I think the mechanics around it have always, to some degree, been ambiguous or flawed.
Certainly not a solid.
I think it's hard. This idea did not come to me until I'd spent time in open source, time in Wall Street, working in investment banks, and then time as an entrepreneur, then finally as a fund manager. Right? Essentially, all these different things have led to, here's how we can put it together. Right? Because it's like all these different facets of a big problem.
Here's a big idea for you. Gosh, let's see this.
This chapter is titled Adam Shares an Idea.
It could be a bad idea. Is like, I'm thinking, I'm in this mindset personally where I'm thinking about my family bank. And I'm not talking about like infinite banking. I'm talking about like ways I can set my family up, that I can be the one who does the hard work to establish the foundation for which my future generations can borrow and lend against, build wealth, have assets, etc. And I'm thinking like, gosh, I love software enough at this stage of my life and at this point in my life for the future family and destination and descendants will come from me, that I want to say this family cares about software, and so much so that it's open source software. I would want my family bank, if this was a thing, to invest into the pool of open source for these things. And it'd sure be great if my foundation I started as a part of it or whatever can benefit because of the value that I invested in open source. Like, that'd be kind of cool. I think you need more of those kind of movements where you have people's long-term generational wealth or lack thereof starts to support open source.
I totally agree. So I've actually, this summer, I've been setting up a family office, which is just a company that holds the investments instead of them, basically it was
asset
driven by
protection, et cetera. Yeah.
It's driven honestly by the fact that my taxes have gotten complicated and they're breaking me. And so I'm like, oh, I just need to push that to another organization that handles that. And so, but it's exactly that. And then that's gotten me in the family office community. There's a big community out there of family offices, family
Huge.
banks, right?
We're in similar circles then, because I'm doing the same thing. I'm trying to figure out that stuff.
Exactly. Well, we can share notes on that on the side. I'd love to connect, share what we're trying to do. And there's just a lot of ways to do it. But I agree with you. There's a big world out there. And why not, as people become prosperous, have a way to kind of extend and help the world be better. The AI revolution is here. It's coming. The AI transformation is here. I want it to make more people wealthy. And not just a few people, but like a lot of people. And then pass that on. I want a world of peace and prosperity. I'm naive enough to still have that dream, but I actually believe it's possible with good ideas, with the right ideas. But there's also, there's roadblocks and there's potholes and there's bad directions to go. And so that's why information matters. That's why cooperation matters. That's why I think open source communities can be a part of it, because in open source communities, you have real people working together to do something. And that's how anything great is done, is real people, real communities. And how do you then help them and allow lots of them to flourish?
Yeah.
So yeah, this is really good. And you're exactly right.
It's like art,
family banks,
right?
Yes.
A lot of family offices invest in art for obvious reasons, right?
Yes.
Open source is art, right?
Yes.
It's an
you're right.
class we've never been able to invest in.
Yes,
but I
you're
believe
100% right. You're 100% right.
19 years of my life chasing it, exploring it, sharing it,
Have you been to Italy and to the Florence and seen the great artists of that era? And you realize how when I went 2 years ago, I finally realized, it was concentration of these patrons that sponsored Michelangelo. Like, they didn't come out of nothing. It came out of a concentration of wealth that was then distributed to the people to enable them. It was patronage that enabled that, right? And you're exactly right. We need the same kind of thing, but not just with a few wealthy people, but how do we do it for millions of people to participate as the patrons?
Yeah.
And in return, they're benefiting.
It's got to function first. So I think that's where the hard part is. You need to get that $500,000 per year for the next 5 or whatever it is and do it.
That's right. That's right.
Figure out how to get past that.
To partner with somebody else.
You need that first.
I totally agree with you. That's what drives me right now is, doing these other things. I still got to make a living myself. I'm not quite at the point where I can just focus on this. I've got to figure out how to, I've got clients and other people I'm supporting so I can, support my family. And then, but you see the idea of, eventually I might have some means to invest. Cool. What am I going to do with that? Man. And that's where this came from. Awesome. Super good to talk to you guys. You guys are awesome.
This was
Jared,
great.
Adam, loved it.
Let us know as you make progress.
I will. Yeah, absolutely.
Be part of it. Help spread the word.
Definitely stay in touch.
Cool.
Definitely stay in touch. Love talking to you all.
All right, Travis. Thanks so much for being on the show, man.
Okay. Take care, my friends. You guys have a great day. Bye.